This lesson is on algebraic vectors, and there's tons of information that we could be doing with vectors. I'm just going to narrow it down to the few things that you'll probably be needing for this class. So a vector is a quantity that has a magnitude and direction, and you may have dealt with these in your physical science or physics classes. Magnitude is represented by the length of the arrow that you draw, because you do represent these on a graph with an arrow, and the direction is the angle at which it's kind of pointing. So again, this vector quantity has both magnitude and direction. You do deal with these in other classes. For example, velocity is considered a vector because you have a speed and a direction that you are traveling. So it is the same kind of stuff, but we do a little bit different things with it in here. The way that you name a vector is you can either use a lowercase letter like this, or it may be called that in the problem, and it has a little half arrow. The arrow will always point to the right, even if the vector doesn't point to the right. It's just the way you name it. Or you could be using two capital letters, and usually that happens if they've given you 2 points and you're figuring out the vector between those 2 points. But again, in either case, you have the little arrow that has half of a thing, and it always points to the right. Magnitude, again, I said it's represented by the length, and so the way we find length in math is the distance formula. You should recognize that. Sometimes you can think of it on the graph and do Pythagorean theorem, which is basically the same thing. So we're probably going to be using this distance formula the most, but if you do graph it, you can just use Pythagorean theorem and figure out that same length. It is the length of the arrow. Okay, let's go to some examples of what we'll be doing. Alright, first we're going to find an ordered pair that represents the vector from point A, which is 5, 4, to point B, which is 0, negative 3. And so A is at 5, 4. So right here. And B is at 0, negative 3. Right here. And so we want the vector that's between those. So it goes from A to B. And again, they tell us that from A to B. And in the name, the A is first. So that tells us also that we started with the A and ended at the B. Okay. This represents magnitude. And as you'll notice, and I forgot to mention, that magnitude kind of looks like absolute value bars. So if you see those, that does mean the magnitude, which is this distance formula. Okay, how to find the vector. There is kind of a formula. You want to do basically this point that you end with, subtract the point that you started with. Now, when you write it as a vector, you want to use not parentheses, not square brackets. They're special brackets. Now, some textbooks use different looking brackets, but they'll be something special. I'm going to use these because this is what I'm used to. Just they're kind of arrow looking. Instead of parentheses, they have that little point to them. So again, take the point that you end with and subtract the point that you started with. So for the first part, it's going to be 0 minus 5. Then I'm going to put a comma. And then the second part will be negative 3 minus 4. And so that's going to simplify. So you get negative 5, negative 7. Now, what that tells me is that on the graph, to get from A to B, I have to go left 5 and down 7. So these are kind of like directions to go from one point to another. Now, the magnitude of AB is, again, our distance formula. So I'm going to square root, and I didn't put the little x1s and x2s and y1s and y2s because it doesn't matter which way you subtract, it'll work out. So I'm just going to do 5 minus 0, you could do 0 minus 5, squared plus 4 minus negative 3 squared. And so that will be 5 squared plus 7 squared. And so that's 25 and 49, and that ends up to be the square root of 74. And you may see this broken down. You may see it as a decimal, 8.6. But that either one of those is acceptable as the magnitude of this vector. So this is the vector, the ordered pair. So that's the first part that they're asking for, and then this is our magnitude. Now, before I go on, I do want to point out that in the future, we may already have the vector, not necessarily 2 points. They may give us this vector, and the magnitude of that vector, if they don't give you 2 points, is still the distance formula, except think about it. We subtracted x's to get this, and we subtracted y's to get this. So that's really what you'll get in those two parentheses, because if I stick these in, negative 5 squared plus negative 7 squared, that's the same thing as 5 squared, because two negatives will make a positive, and 7 squared, which, 25 and 49 are what we get here as well. So again, if they don't give you don't give you 2 points and they give you the vector, just do this part squared and this part squared in your distance formula. And I'll do some of those in a minute with some other problems where we need to find magnitude. Now, this is probably the easiest thing that you'll find that we do. Super simple. We're given two vectors that are already vectors, not points. So you have those special brackets again. That's how I know it's a vector that goes from whatever point it's at, right 3 and up 9. And this vector goes left 1 and up 6. But when you make calculations with these, it's as easy as it looks. So when they say vector q plus vector r, they really mean taking the vector q and adding it to the vector r exactly the way that you think it should happen. So add those first two, so 3 and negative 1 is 2, 9 and 6 is 15. It's that simple. That's your answer. So with subtraction, be careful. Just make sure you get your signs right. So in this case, I have q minus r. And so I want to make sure I do 3 minus negative 1. And then again, in that case, I have two negatives, which make a positive. So 3 minus negative 1 is the same as 3 plus 1, which is 4. And then 9 minus 6 is 3. So just be careful with signs when you're doing subtraction. And then 5q, you just do 5 times whatever q is. And so 5 times 3 is 15. And 5 times 9 is 45. It's just, when you do these, you're getting a vector answer, so you still want to use those special brackets. But anytime you see this kind of question, it's just as easy as it looks. There's nothing to it. Okay, the next thing we'll talk about is unit vectors. If they talk about unit vectors, that means it's a vector that goes with the x-axis or the y-axis or parallel to it, and they're only 1 unit in length. So those actually have special names. Vector I is the vector 1, 0. So it's going to go right 1. And so it's going to look something like this, and the length of it is going to be 1 unit, whatever that is, on your graph paper. Vector J is also special, and it does keep that name, and that is the one that goes 1 unit up. And so it didn't go left or right. The positive 1 tells me it's 1 unit up. A vector J would look something like this, and again, it is 1 unit long on your graph paper. So if you're going right, it's I. If you're going up, it's J. Now, if those were negative, that would mean you were going left or down. So those they keep the I and the J. So our example here of using these unit vectors is they would say, write this vector CD as the sum of unit vectors, and they gave you points. And you can tell they're points because of the parentheses that are rounded, and the letter in front of them. And so this vector goes from C to D. We have to find the vector first. So vector CD will be the -4 minus the 6, because we ended with the D, that's the one you start with in the subtraction, and then 8 minus 3. So that will be -10 and 5. So now that I have it written as a vector, I can also write it as the sum of unit vectors I and j, and you just take the two numbers that you have in your regular vector notation and stick I and j vector with them. So I'll say -10I vector plus 5j vector. And sometimes they don't give you 2 points. They'll go ahead and give you this vector to start with, and you just write it. And it, again, seems kind of stupid and easy, but it does have meaning in other things. And if any of you go on further in math, you'll do a lot more with it. But for right now, we're going with that basic. Okay, sometimes you come across problems, and it's really important to tell whether the vectors are perpendicular or not. And so they have this thing that's called the dot product or the inner product, and it just depends on what textbook you're in as to what it's called. I tend to call it the dot product just because that's what my professors used. So the dot product, if it is 0, then the vectors are perpendicular. But if you get any other number, then the vectors are not perpendicular. And so what the dot product is this formula over here that I have in bold. Okay, so you'll be given two vectors, and here I'm having just generic ones, A and B. And I'm already in the vector form because I have the funky brackets. And so I have A1 is the first piece, A2 is the second piece, and B1 is the first piece, B2 is the second piece here. To get that dot product, and it does look like a little dot between the two things, you multiply the first numbers together from each one, and then add it to the second numbers multiplied from each one. And again, if that is 0, they're perpendicular. If it's not 0, they are not perpendicular. So let's practice a couple of those. Our example gives us 3 vectors, A, B, and C. And we have them already in the vector notation. They didn't give us points. We don't have to do that extra math here, that extra work. Is either pair, A and B, or A and C, perpendicular? So the first thing I'm going to do is A dot B and see if I get a 0. So looking at A and B, I take the first two numbers and multiply them. So 3 times 8. Add, and then multiply the second two numbers. So 12 times -2. Well, 8 times 3 is 24, and 12 times -2 is -24. And so when I add those, they do end up to be 0, and that tells me that vector A is perpendicular to vector B. So yes, these are perpendicular. The second thing they wanted me to check was A and C. So I'm going to check vector A and vector C with the dot product. So I do the first one in A and the first one in C. So 3 times 3 plus the second one in A and the second one in C. 12 times -2. So I get 9 plus -24, which is -15. And since I did not get a 0 here, I know that vector A and vector C are not perpendicular. Okay, the last thing that we're going to look at is how to find the angle between two vectors. We deal with angles and lengths a lot in this class, and the trig that we do. And so this is very important. You also need to memorize this formula because it will not be given on your formula sheet. So star it, circle it, do something. It needs to be memorized. The way we find that angle, this formula has the cosine of the angle is going to be equal to the dot product of the two vectors over the magnitude of each one of them multiplied together. So I have a couple of examples of this. So for example 5, we're going to find the angle between vector A and vector B. So the top of that formula tells me I need to do the dot product. So that's what I was just doing on that last example. So I'm going to do the first number times the first number plus the second number times the second number. And in this case, I have 12 plus 12, which is 24. And they're not perpendicular, but that's not what I'm trying to find. So if they were perpendicular, obviously the angle between them would be 90. So you're probably not going to get that very often in this kind of problem because they're going to want you to do the work that goes with the other parts of the formula. On the bottom, we have to know the magnitude of vector A and the magnitude of vector B. And this is what I was trying to explain in that first problem. When I'm trying to find the magnitude and it's not 2 points, all I need to do is square root of the first thing squared plus the second thing squared, because those are x minus x and y minus y. It's how we got those numbers. So in this case, I have 9 and 16, which is 25. So the square root of 25 is 5. So that's the magnitude of A. Then I'm going to do the magnitude of B. And it's going to work the same way because it's already written in vector form. So I have 4 squared plus 3 squared, and obviously it's the same thing I just did, it's just in reverse, so I know it also comes out to be 5, which isn't always going to be the case, but for these examples I chose it seems to happen. So now we go back to our formula, which says the cosine of theta is equal to the dot product of the two, which was 24, over their magnitudes multiplied together. So I have the cosine of theta is 24 over 25. But the question wants to know the angle, not the cosine of the angle. So I have to think, how can I get that? And that's just doing my inverse. So cosine inverse of 24 over 25. You want to make sure, in this case, let's all be in degrees. So check the mode on your calculator and make sure you're in degree mode. And if we do the cosine inverse here, we get something about 16.26 degrees. And that's our answer. So let's try our next one. If you want to pause and try this one on your own, this is a good time to do that. If not, just follow along and I'll continue with my explanation here. So again, for our formula, we need to know 3 things. We need to know the dot product of A and B, the magnitude of A, and the magnitude of B to be able to plug those numbers into our formula. So our dot product says the first times the first plus the second times the second. So I get 35 plus 5, which is 40. And again, they're not perpendicular. If they were, there would be a 90-degree angle and we would be done. The magnitude of A, I'm going to do the square root of 7 squared plus 1 squared. So that would be 49 and 1, so I have the square root of 50 here. And then the magnitude of B, I'm going to do 5 squared plus 5 squared. Well, that's 25 and 25, so I'm also getting the square root of 50. And like I said, it's not always the case that these match, but it just happens to in the examples I chose. So put them into the formula. The cosine of our angle is going to equal our dot product over our magnitudes multiplied together. Now, before I go on, notice that on the bottom, I have the square root of 50 2 times, so that would be the square root of 50 squared. And that square root and square will cancel, so I actually have 40 over 50. And that will reduce, because they both can be divided by 10, to 4/5. So a better equation here would be 4/5, a lot easier to work with. Now I want to find the angle So I have to do the inverse, so cosine inverse of 4/5. Type it in, making sure I'm in degree mode if I have changed that, and I get 36.87, which is degrees, so I put a degree symbol. That concludes this lesson. If you have any questions, make sure to ask. I'll help you as much as I can. Thanks.